All right, let's go ahead and talk about what we need to know for retaking the Unit 1 test. So right now your audio should be on. This is a video that I'm kind of going to go through a PowerPoint. All right. First of all, what you need to know are the rules for the retake. All missing assignments that are in gradebook must be completed by Thursday. That's only if you're watching this on Monday, Thursday, October 8th at 5 p.m. Everything's available in Canvas. And there will also be an extra remediation lesson that you will need to do after you watch this video. And Thursday night, I will go in and see who's going to be able to take the retake. All right, so this is a hard deadline. No excuses. Got to be done by Thursday at 5 p.m. If you were absent and you never took the original test, you will still need to have all these assignments completed and gradebook that are in gradebook to be eligible to take a retake. So even if you don't know, I wouldn't take my chances. I would make sure that you're able to do a retake, and you have to meet this Thursday deadline. The retake will be given in class on Friday, October 9th. After that, there will be no more chances to take this test again. All right. We had some definitions. First, we had what is a point, and that is just a location. It has no shape or size. And on this picture, we have point X, we have point W, and we have point Y. Every other letter on here is not a point. It is referring to either naming a line or naming a plane. So the only points on here are X, W, and Y, and we know that because they are all capital letter and they have an actual point notation with them. So I would say point X, point W, point Y. Then we talked about what is a line is put all those points together. They go infinitely in either direction, left or right. So right in this picture, we have line XW. It is notated with 2 points or the little lowercase letter. So we could call this line N or we could call it line XW. This would be line M and this would be line L. So you're looking for that lowercase. This could be line K. If you don't have 2 points, you have to name it with the lowercase letter that you see. All right, after that, we had a line segment. A line segment is just exactly that, a part of a line. It has 2 endpoints. So in this picture, we could say that we have line segment XW. It is the points between X and W. And it is named XW or WX. Either one would be correct. All right, and then we had a ray. A ray has an endpoint and it goes in one direction. So in this case, we could say, we could name ray XW going this way. We note it like this, XW with an arrow going in that direction. A ray is directional. So XW, notice the difference, we name it this way, but if we wanted to refer to these points, we would name WX, still going from left to right. W, the endpoint goes first and then X, even if the ray is facing a different direction. All right, then we talked about a plane. The little blue areas are planes. Plane is a 2D surface, but it does extend in all directions. We just need to visually have boundaries so we can know what plane we're talking about. But this is a 2D surface. It goes on in all directions. We have to name a plane with 3 points or the letter on the plane. So this plane we could call plane A. We know it's not a line. It's not referring to a line for one reason, where it's located, and the other reason because it's an uppercase. It's kind of a scripty uppercase. All right, we don't have a third point on this plane or any of these planes, but we would need one if we wanted to call it by points. So we could call this plane CXW if it had a third point on it. All right, the place where a line and a plane intersect is a single point. So in this case, line M is intersecting the plane at point X. Two planes intersect each other at a line. So these two planes are hitting each other at line K. All right, so that's pretty much a rundown on definitions. So let's move on to segment addition. I'm just going to hit this real quick. It wasn't on the test, but what the simple idea here, it just says that segment DO plus segment OG is equal to segment DG. All right, that should not be a hard example. We had equations, then you could say that DO plus OG is equal to the whole thing, DG. In this problem, DG was 60. And you could continue to solve that for the variable to find out the actual length of DO. Okay, I'm not going to take time to do that now. All right, find midpoints. Midpoint formula. The middle is always equal to the ends divided by 2. The middle is always equal to the ends of the segment divided by 2. So on these two, my ends are 5 and -4 for x. So x, the middle point of x, is 5 minus 4 over 2, which is 1 over 2. So 1/2 would be the middle coordinate. And then for y, I've got 12 plus 8 divided by 2, and that equals 10. So the midpoint of this segment would be 1/2, 10. All right, excuse me, my voice. X, the middle, equals the ends. All right. So that would be -1.5. Y, the middle, equals -2 plus 1 divided by 2. -1 plus 1 is -1, -1/2. So this point, you could call it, we'll just go with -3/2 and -1/2. All right, simply add up the ends, and that equals add up the ends divided by 2, and that equals the middle. Now, finding the coordinates of a missing endpoint. Same formula, the same way to do it. You're just going to have variables in different places, because now the missing endpoint is the point EG is over here, XY. So we have E to G and a midpoint at P. All right, so the middle, still the same thing. The middle equals the ends divided by 2. To solve this, I've got to multiply both sides by 2. All right, the 2's cancel out on this side, which is why I did that. So I get rid of the fraction. And then I solve this using algebra. And you've got x equal -2. We're going to do the same thing for y. The y middle is 10 equals the ends divided by 2. Multiply both sides by 2, and 20 equals 6 plus y. Subtract 6 from both sides, y equals 14. And that is my missing endpoint. Okay, so you're going to do the same thing over here. XY is your endpoint. So you're going to add the ends and set it equal to the middle. 5 equals -1 plus x. Solve it. Add 1 to both sides. All right, your ends. 3 plus y over 2 equals your middle, 6. multiply both sides by 2, and 12 equals 3 plus y. Y equals minus 3 both sides, and final answer 11.9. All right, distance formula. It turned out on the test you didn't have to calculate any distance formula, but let's go through it. Distance of your x points, 8 minus a minus 5 squared, plus your difference in y's, negative 4 minus 6 squared. I didn't write the formula up here. Let's do that. Difference of your x's squared plus the difference of your y's squared. Plug in the numbers and then just start calculating. 8 plus 5 is 13 squared. Negative 4, negative 10. Negative 4, negative 6 is negative 10. 13 squared is 169 plus negative 10 squared is 100. Square root of all of that is 269. This one, if you do it in your calculator, does not turn out to be a perfect square, so you would just put down the decimal. Okay, and we will move on. All right, segment partitioning. So I've got an extra example out there on Canvas, but let's talk about a different way to do segment partitioning. There's lots of ways to do these problems. This is the method that you would find on Khan Academy, and I've been thinking that the other method where you set up a ratio is easy, but it has a lot more algebra to it. So if you're struggling with your algebra and having to solve those equations with variables on both sides and with distribution, then let's try this way and see if that works out better for you. All right, so again, I'm going to start by drawing a picture. I'm going from A to B at negative 3, 1 to 4, 8. All right, and we are partitioning at point P in a 5 to 2 ratio. All right, for this method, I need to take that 5 to 2 ratio, 5 to 2, and think about what fractional distance is this point away from point A. So we got point A, point B. All right, so there's a total of 7 parts to this partitioning, and we are at 5 out of the 7. So we can say that point P is 5/7 of the distance, or of the total distance from A to B. Okay, this is A, this is B. So that's the idea. Here we go. Let's calculate it now. We have we've got to start with our x value. We're going to do this once for x. So we're starting at negative 3, and we're going to go 5/7 of the total distance. Well, 5/7 of the total distance of AB. What is the total distance of AB for x? Let's figure that out. For AB, from A to B, is the difference of 4 minus a minus 3. 4 minus a minus 3 is 7. So the total distance is 7. So from negative 3, 7 over 7 cancels out and becomes 1. Negative 3 plus 5 is positive 2. So this point is going to end up at 2. All right, and then their y. Same idea. We're going to need the total distance for AB for y. Well, y goes from 8 to 1. 8 minus 1 is 7, so it's also 7. All right, and then we're going to start at 1. Oops, sorry, let me go back. Hope my annotation. Okay, we're going to start at 1. We're going to go 5/7 of the total, which is 7. So 7 over 7 is 1, and 1 plus 5 is 6. And that's all you do for this method. So our y value is 6. Now we looked at on this problem in every the fractions canceled out. You may end up some of these have fractions or fractions that you have to reduce. Okay, let's go on. We are looking, the next thing is parallel and perpendicular lines. So we needed to be able to look at these different forms of a linear equation and know if what the slopes are. So here, this is the slope on slope-intercept. This is its y-intercept. Oops, sorry. This is the slope when you're in point slope form. That one's not as common, but you may see it. And then in standard form, we have to actually calculate it. So if we have 3x plus 5y equals c, I can do one of two things. I can turn this into, let me put a number here. I can turn this into y equals mx plus b by just solving for y. Would be like this. And then I would divide both sides by 5. And y equals negative 3/5 x plus 12/5. All right. All I'm really interested in for this problem is this slope right here. So every time I do that, I'm doing the same thing. I'm taking the opposite of a and dividing by b. So I can just remember that when I see standard form, I'm going to take the opposite of the a and divide it by b. The opposite of the coefficient of x divided by the coefficient of y. So let's take some examples and see. Well, first we're going to talk about what it means to be parallel and perpendicular. All right, two lines that are parallel. They're never going to touch each other. They have the same slope. So we say that line M is parallel to line N, and that's the notation for parallel. So they never touch each other, and what we know is that they have the same slope. Okay? These lines are perpendicular. They form a 90-degree angle, and their slopes are called, well, let me say perpendicular. The symbol is this. So we could say that segment XY, line XY, perpendicular to line AB. Okay? And their slopes are the opposite reciprocal. And what that means is that if I had one slope of 3, the other one is going to be the opposite of it and flip it. So 3 becomes 1/3. All right, if you had negative 2/5 as one slope, the other one would be flipped and it would be positive. So that's what it means to be an opposite reciprocal. All right, so let's try some. Let's look at these two equations and see if they are opposite, if they're perpendicular or parallel. Parallel slopes are equal, so I'm going to look right here, and that is parallel slopes because they're equal. I'm going to look right here. These are opposites, but they're not reciprocals, so this is neither one. I'm going to look here. I got negative 1/4, but now I got 2. Oh no, I got 4. So those are, well, let's check. They're opposites, but are they reciprocals? If I take 1/4 and flip it, I would get 4/1. So yes, that is perpendicular slopes. All right, now I got to convert it. So I've got this slope right here is a negative a over b. This slope right here is a negative a over b. Simplify those negatives. This slope is 7/2, and that's negative 2/7. So they're opposite and they are flipped. So that is perpendicular. Here the slope is negative 5. Here it is negative 1 over negative 5. Simplify the negatives, 1/5. They are opposites and they are reciprocals. So this is perpendicular. All right, let's try this one is negative 3 over 2. This one is negative 2 over 3. They're both negative, so they're not opposite. So we know this is neither one. Right here, Negative 4, this is negative 8 over 2. That's going to simplify to negative 4. Negative 4 equals negative 4, so these are parallel. All right, we've got this slope is negative 1 over 1. This slope is negative 1 over negative 1. Those simplify to become 1. This simplifies to become negative 1. If I flip either one of these, I still get 1 over 1, and they're the opposites of each other. So they are flipped, and they are opposite. So this is perpendicular. All right, last one. 1/3. This is negative 1 over negative 3. Simplify, that becomes 1/3. 1/3 equals 1/3, so these are parallel. All right. Now let's use that for the next thing. We have to be able to write an equation of a line that's either parallel or perpendicular to another line that they give us and goes through a certain point. So let's see how we do that. All right, there's going to be 4 different types of problems here. You're either going to be writing parallel or perpendicular, and you're going to either be given standard form or slope-intercept form. So that makes 4 different scenarios you could come across. I'm going to do 2, and then you should be able to piece together the other 2. So here, first step is to find the slope of the line that you're given, slope of the line that is given. So in this case, that slope would be 1/3. Then I need to find, based on what I'm told to do, find either the parallel or the perpendicular slope. So in this case, I need a parallel slope. Well, that's equal. So my slope is 1/3. Then I need to find, so now if I'm writing an equation, I have y equals, I already know my slope. I just need the b part. So I'm going to find that by using y equals mx plus b. I'm going to substitute everything I know about my point. My line is going to go through this point, so that's 5 equals 1/3 slope times x, which is negative 3, plus b. Now I can find the intercept that I need. So I'm going to multiply 3 over 3 is 1, so I get 5 equals negative 1 plus b. Solve that for b, and now I'm going to put that in place and rewrite my new equation. It'll be y equals 1/3 x plus 6. All right, let's do another example. This is not written like normal. Normally it would be 5x plus 3y. That's where I messed up. Okay, this is in standard form. So that means our slope is negative 5 over 3 for this equation. My perpendicular slope that I need is the opposite of that, and it's going to be 3 over 5. Okay, now we can go back to where we were. 7 equals 3/5 times x, which is negative 5, plus b. Okay, and then that cancels out, and now I have 7 equals negative 3 plus b. b equals, add 3 to both sides, and then I can say that y equals my new slope times x plus 10. Okay. So here's what you'll need to do. On Canvas, there will be a remediation assignment. And since then, I've also posted an extra video on the new way to do segment partitioning. Complete that assignment on paper. Take a picture of your work, show all your work, and upload it to Canvas. And that has to be in to me by Thursday at 5 p.m. Because Thursday night, I will go and check and see who has done all the work they need so I can make a list of who can take the retake on Friday. All right, and hope this helps. Feel free to email me or post on Remind if you have any more questions, okay? Thanks, bye.